Wow, great video, and welcome everyone to session 6 of the UNESCO IWRA online conference on emerging pollutants, protecting water quality for the health of people and the environment. And my name is Marjin Korndewal, and I work at the Organization for Economic Cooperation and Development, or OECD in short, as an analyst on water quality policies. And together with Dahlia Sabri, who is the Deputy Resident Engineer at KEO International, I'll be moderating this session. The theme of this session is a circular economy approach, life cycle management of emerging pollutants. And in this session, we will be zooming in on the full life cycle of pollutants, meaning we will not only consider the sources and their fate in water, but also what happens in between and what happens in their afterlife. Who uses these pollutants before we mark them as a pollutant? And is there any way we can repurpose the pollutant, between brackets, and give them a new life, or a so-called circular economy approach? Now, this session will dive into several emerging freshwater pollutants, such as antibiotics and psychiatrics, harmful algal blooms, chlorine residual colorants, but we will also learn more about the health effects of emerging pollutants, for example, on urban populations. And we will be provided with some policy suggestions. Now, before we dive into 8 interesting presentations, I would like to ask your attention for some practical matters. This session will be recorded, and we invite you to submit your questions in English via the Q&A button at the bottom of your screen. We will try to address your questions as much as possible after the talk, during a Q&A session, or in writing. And once the question has been answered, it will be displayed in the chat box. So a request to all the presenters, please keep an eye on the chat box as well to see if you can already provide a written response. And as we have a large audience, we do not expect to be able to respond to all of your questions. So whichever question we cannot answer right now, you'll get a written response afterwards on the conference website. Please note the chat box is disabled during the session, but it will be used to post announcements by the organizing committee. If you want to engage further in discussions, please go to the GWP toolbox. A link will be provided in the chat box. If you wish to have subtitles, you can turn them on at the bottom of your screen. And if you experience any technical problems, Google always gives good advice, so search for Zoom Help Center, or send an email to online.conference@iwra.org. Those are my few housekeeping messages, and now on to the substance. We are very proud to have Professor Dr. Styliani Avraamidou as the keynote speaker of this session. Styliani Avraamidou is the assistant professor at the Department of Chemical and Biological Engineering at the University of Wisconsin-Madison in the United States. She's a leading expert in systems modeling and circular economy. And having gone through some of her papers, I think she has a particular interest in the area of the food, energy, water nexus. Styliani, you have the floor. You have about 10 minutes, and after your presentation, your audience can ask questions. Go ahead.
Introduction and for the invitation to present in this online conference. Again, I'm a chemical engineer working on circular economy, looking at food supply chains and chemical supply chains. And in the past, I have been also looking at food, energy, water nexus. So today I will present to you like an introductory presentation about what circular economy is, how we can apply it to different supply chains, and how we can use those principles to apply them more to water circularity. Next slide. Yeah, so that's an outline of my presentation. We will define circular economy. We'll go over a supply chain for coffee, and then we'll go over the framework that we have been developing in my group to holistically consider these circular economy supply chains. Next slide. Okay, so that's how the coffee supply looks like. We somewhere in the world, this brown shaded region, we produce coffee, we cultivate coffee, we collect the coffee cherries, we process them into what is called the green coffee, then we ship it around the world, where we further process it, roast it, and then deliver it to our grocery stores and coffee shops for us to enjoy our coffee. And through this whole supply chain, can you go to the next slide? There is a lot of waste being created, water being consumed. Like for just 1 cup of coffee, that's just 10 grams of coffee, we're using 140 liters of water. Huge amounts of energy, a lot of organic and plastic waste throughout the supply chain. And that's not just the case with coffee, but the entire food industry, where it's consuming 30% of the world's energy, and 80% of the water that we consume are going to the food supply chains. Okay, next slide. Going into a bit more details of what's going on in the coffee supply chain, we see that we have waste coming up at every single stage of the supply chain, and water being contaminated, mainly at the cultivation and processing stages. So we are creating waste, we're using natural resources throughout, and we're using energy at every single step, and that energy is mostly coming from fossil fuels, creating emissions. And that's a classic representation of what a linear supply chain is. Next slide. What is circular economy? Again, linear is when we're using all these resources, processing them, creating waste throughout the supply chain, using the product, and then creating a lot of landfill waste, versus a circular economy where we're trying to limit the amount of resources that we're using, keep our materials looping in the supply chain for as long as possible, eliminating waste, and at the end, resulting to limited landfill waste. Next slide. Okay, so how we define circular economy, many people and many organizations have defined circular economy. This paper from 2017 was analyzing 114 different definitions of circular economy, and circular economy is supposed to be this well-defined thing that we know what it's meant and how we can implement it, but the reality is that we don't have a consensus of what it actually is. Looking at all these definitions, we can identify 5 main key points: to reduce material losses, reduce the use of natural resources, increase the use of renewable resources and energy, reduce our emissions, and increase the value durability of products. Next slide. Okay, so this concept of circular economy has been promoted throughout the world. Many businesses, organizations, governments are promoting this concept. And the reason why this is in everyone's languages is next slide. We believe that these rising populations put huge stresses on our natural resources. All this waste has huge environmental impacts. Water is something that we're really out of in many areas of the world. And by implementing this circular economy approach, it is believed that we will have a positive impact on both the economic, environmental, and social sustainability. And that's a quote from the World Bank saying that circular economy could aid in both economic, environmental, and social aspects of the water supply chain. Next slide. Okay, so water, from kids, we learned that the water is circular, and we learned about the water cycle, and everything should be water fine, and this could actually be a very nice example for circular economy, but this somewhere breaks, and we have all these pollutants that are mixed with our runoff or surface water, and then we don't have precipitation where we want it to be. We have climate change, so this whole cycle breaks in many areas of the work. And then next to this, I have a representation for the circular economy of water by the World Bank again, that we can clearly see that water is not the only resource that plays into this game. We have energy that is very important and nutrients. And when we think about circular economy, we usually think just about material flows, and that's a mistake. For the water cycle to be happening and for circularity of water to be happening, we need to have huge amounts of energy coming into the picture. And these studies looking at energy-water nexus are very important, and a systems analysis is very important when considering decision-making for circular economy water supply chains. Next slide. So I will briefly introduce you to a framework that we have been working on in my group, looking at how to systematically consider these huge supply chains. We had been looking mainly at food supply chains, so I will use again this coffee example to go through the framework, and we have been using mathematical modeling and optimization to achieve our system analysis. So I will go over each of these steps. Next slide. Can you go to the next slide? That thing. Okay, so the first step is to consider all the alternative production pathways for our main product. In the case of coffee, we have two main production pathways, the wet method, the dry method. I will not go into too much details, but the wet method is using a lot of energy and a lot of water versus the dry method needing a lot of time and space. So we already have some trade-offs there. Next slide. So the next step is to collect all the different waste that are happening in our supply chain and figure out different ways to utilize those wastes. And for the organic waste that we had from our coffee supply chain, we can use them for many different products and processes. For this case study, we just focused on the energy producing utilization pathways. So we identified those energy producing pathways. And next slide. We did some research and found out data and parameters for producing biodiesel, bioethanol, biogas, and all the energy products from our coffee waste streams. Based on this experimental data from all these papers, we were able to create models for each of the processes that I have here. Next slide. Okay, so based on all this data that we collected about the production processing pathways and then the alternative pathways to reuse waste and produce energy, we developed this diagram. This is called an RTN network, where each of the boxes is another process, each of the circles is a resource, and the brown boxes are the main processing pathways, the greenish boxes are the waste processing pathways, and then we have a blue box here for the water recycling that we need in the wet processing as an alternative option if we want to reduce the water needed. Next. Okay, so based on this network, we were able to develop a mathematical optimization problem, and that's what we are known for, creating these big models, where we had different types of variables describing what's happening in the network. We had constraints, and then we have different objective functions. So we use this model to maximize our profit, to minimize the waste, to minimize our natural resources, looking both at water or nutrients, and minimize our greenhouse gas emissions and maximize the energy output of our whole system. So next slide. So this is kind of the results that we get from this type of analysis. These are called the Pareto fronts, where we can see different solutions for our entire supply chain. Here we had 5 different demand scenarios based on what type of coffee we want our system to be producing. We had whole beans, coffee beverages, and instant coffee. We saw that instant coffee was the worst. You can see scenario 4 that is only producing instant coffee is utilizing the biggest amount of both water and coffee cherries. And then the size of the bubble is the CO2 emissions. So we see that that scenario is also the worst. But this kind of analysis can give us different solutions, different options, and then help us accelerate that transition towards circular economy. Next slide. Okay, so another thing is how do we navigate between all those points that I showed in the plot, like which one is the more circular? And what we try to do is come up with some assessment metric to measure this circularity. So we're thinking like, do we just implement environmental goals? Do we just consider economic, social? How do we put all of this together into a single objective function? So what we came up with is to use those 5 characteristics that we identified for circular economy and come up with a score for each of those 5 categories. Next slide. So that's Micron, our circular economy assessment framework. This is for now focused on companies on the at the micro level. So we divided this into different economic sectors. We identify those principal categories from the key characteristics of circular economy, and we were able to use GRI-based metrics to come up with a metric on how well a company is doing in terms of water, energy, emissions, waste, and durability of their products. Next slide. So that's a bit more into what's going on in our Micron calculator thing. So we have the 5 circular economy goals. For each one of those 5 goals, we have a dimension, and you see that we clearly have one specific dimension for water because we really think that's something important in terms of circular economies in general, not just food circular economies. And then we have indicators, metrics, and we give a score from 0 to 1 for each of those goals, and then we average those to get a composite circular economy index. If you're closer to 0, you're linear. If you're at 1, you're ideally circular. Next slide. Okay, and that's just a summary. What we use this metric is for companies to be able to track their transition towards C, so it can be a temporal tool. We can identify which areas really need improvement, and we can compare companies at the same sector with other companies at the same sector. Next slide. Okay, just to summarize everything, I presented a framework for the modeling and optimization of circular economy supply chains, and I also introduced a circular economy assessment tool. I think systems analysis can aid in the understanding, analysis, and optimization of this general circular economy supply chains and help us converge all these different disciplines towards our central vision of circular economy. Future work will be to consider more of these food, energy, water nexus interactions, looking at more of the economics, the time dimensions, and the uncertainty that comes into the supply chain. So I'm sure that many of the speakers will be able to tell us more about these water supply chains in a bit. Next slide. And I want to thank my team, my students, and Texas A&M Energy Institute while I was doing most of my coffee work while I was in Texas. So thank you.
Thank you, Styliani, for your interesting presentation and also for setting the scene for this session on life cycle approaches to pollutants. I'm looking at Dahlia to see if there are any questions in the chat box. And if not, I have a question for Styliani, but let's look at the chat box first.
Actually, Marjin, we don't have, maybe you can go on and with your question, and then we wait, maybe somebody will post the question.
Yeah, sure. And so all participants, please do ask your questions. We would love to hear from you. So don't be shy, don't hesitate. Styliani, I know that so we are looking at emerging pollutants in this session, and one of the emerging pollutants we have nowadays is caffeine. And I assume this comes from coffee, but it could be from energy drinks. I'm not quite clear actually. Did you manage to look at caffeine in wastewater, and is there a circular element to that as well, or is that still rather complex?
Yeah, that's something that we will be looking into the future. We are working with a coffee institute in Texas, and I'm trying to see how caffeine might be getting into water streams, and also how we can, if we use coffee waste in our soil and soil amendments, if that will have any impact on our water streams. But yeah, that's something for the future, I guess, and that's an interesting question. Thank you.
Thank you. Then I guess we'll have to follow you in the years to come. I think it's a question many of us have. So thank you so much for this introductory, for this keynote, Styliani. It's really appreciated.
Thank you for the invitation. Yeah.
So we will now go to the presentations of the abstracts. And we have 7 presentations for you in store, highlighting different aspects of the life cycle of emerging pollutants. So to all the participants online, please share your questions and comments. We love to hear from you. And to all the presenters, we also love to hear from you, but also stick to the time that you've been given, you've been allocated. You'll see a timer in the bottom of your screen, which shows you how much time you have remaining. So now we, Júlia, Carolina, Braz, de Freitas, Bijos will kick off with a presentation on occurrence of antibiotics and psychiatric drugs in Brazilian municipalities. And she has used a data analysis approach. Júlia, I hope you're ready to present, and we love to learn from you in the next 10 minutes. Over to you.
Hi, good morning. So my name is Júlia. I'm from Federal University of Bahia, located in Salvador City in Brazil. And today I'm gonna share with you the first step of my PhD research, entitled Occurrence of Antibiotics and Psychiatric Drugs in Brazilian Municipalities, a Data Analysis Approach. Next slide, please. It's okay?
It seems like there is an error in forwarding the slides. I'm looking at the organizing committee. Yeah, it seems to be working now. Go ahead.
Okay. Are you gonna share the time, or it's better for me to put my clock here? Well, so I have some important points to tell specifically about Brazil. The country is the 8th largest pharmaceutical market, and it's the main market from Latin America. And this poses a concern because we know that the pharmaceuticals that are consumed, they are not completely absorbed by our organism. So we tend to excrete some ranges of active compounds that will follow to wastewater treatment. And we know that in wastewater treatment plants, the conventional treatment applied has a poor removal efficiency for such compound. And this problem gets bigger when we think that Brazil, that it's a big country, it still has limitations in the sanitation field, like less than 50% of the population has a proper access to sewage collection and sewage treatment. So the population is very vulnerable to sewage diseases. And this is also consequence or reflects some ineffective legislation, because as other countries, we don't have specific regulations for pharmaceuticals active compounds in water bodies or in wastewater effluents. So we have two specific regulations about the patterns to release wastewater effluents in water bodies. And we have another regulation about the drinking water parameters. And in that regulation, it was recently updated with some kinds of pesticides, but still now nothing about pharmaceuticals active compounds. So all the situation enhances the need for we improve our monitoring, our controlling actions, our knowledge about those substances in our environment. As we know that this monitoring, this controlling is done by sparse sampling campaigns performed by researchers, by research groups. But we know that Brazil is a big country, so it does not cover, obviously, the whole country. So it's a very limited situation, and that enhances the need for finding some ways, like modeling methods, like different approaches to help this monitoring in this control. Next slide, please. So the main objective from my research is to investigate the pharmaceutical occurrence in the environment based on sales data through statistical data analysis. And the specific objectives is to know Brazilian municipalities with greater recurrence of active compounds quantification, to verify the most investigated pharmaceuticals, and to estimate the load of active compounds to be treated in wastewater treatment plants based on the sales data. You can go ahead, please. And so I performed 4 main steps. Of course, first of all, I did a bibliographic search to gather research papers that quantified active compounds in surface waters and especially in sanitary sewage. And of course, I looked in these papers for Brazilian papers because I wanted to know where these researches were being conducted. And since I wanted to use sales data to do my estimation, I performed the data collection from government databases, open database. So I collected sales data from pharmaceuticals from 2014 till 2020 from Anvisa, a national agency of regulation of pharmaceuticals in Brazil. And I also collected some data of wastewater treatment plants in Brazil, like some data like type of technique applied and other criterions from Brazilian agency, National Water Agency, it's called. And then I performed data analysis to know this data better. I performed this data analysis in RStudio, anti-diverse library. And then after all this pretreatment, I made the estimations of the concentrations. So I did the estimation considering the total mass of active compounds sold and the human excretion factor of each of the active compounds, the sewage flow expected for the municipalities I'm working in, and a conversion factor. You can go ahead, please. So I noted that in Brazil, the active compounds in sanitary sewage are mostly reported in São Paulo state, in those cities, Minas Gerais state, Rio Grande do Sul, and Ceará state. And it makes sense because especially São Paulo state and Minas Gerais state are the most populated states from the country. The most investigated therapeutic classes are antibiotics and psychiatric drugs, and also the data collected from the national agency, it focuses on these kinds of therapeutic classes. And so I decided to work with those active compounds in the table. They are most sold in Brazil, but they are also in the priority lists from many countries. For example, Global Water Research Coalitions, many authors cite them as potentially causing toxicity and risks for human health or aquatic systems. So I decided to investigate better these active compounds. Go ahead, please. So in this first data exploration, I noted that the amoxicillin and azithromycin, both antibiotics, are the most recurrent in the registers. And in basis of the sold quantity, units quantity, it may be a box with many pills, or it may be a bottle with a certain value of liquid of active compound. Amoxicillin and azithromycin still are the most sold, but we can see that amoxicillin has a human excretion factor of 60%, while azithromycin like 10%. And we have the other active compounds like diazepam and carbamazepine. Okay, go ahead, please. So here I brought just amoxicillin and azithromycin because they are the most sold based on quantity of units sold. And as you can see yearly, both of them has the highest concentrations compared to the other active compounds. And amoxicillin, it's about more than 75,000 nanograms per liter, based on my calculations, and it makes sense because it is one of the most sold, and it has also a highest value of human excretion factor. So a great part of what is being consumed is actually being excreted. Azithromycin, despite being so much consumed, so much sold, as amoxicillin, we see that the concentrations are lower, like about 12,000 nanograms per liter. And this happens because of the lower human excretion factor of azithromycin. And again, São Paulo state is the one that has the highest concentrations. So this is an ongoing investigation. I could verify that the monitoring and quantifications of active compounds are mostly performed in São Paulo, and amoxicillin and azithromycin is not only the most investigations, but the most sold active compounds, one of the most sold active compounds in Brazil. And for future research, I intend to investigate better those relationships, considering the evolution of prescription collection in legal terms of the country. And I will check better all these results with previous papers. Okay.
Thank you, Júlia, for your interesting presentation.
Thank you.
you'll get the questions at the end of all the presentations. I think there are one or two, so please stay with us. I would now like to welcome Kei Namba to make a presentation on bio-based and circular solutions for harmful algal bloom and water and climate change challenges in Berlin-Brandenburg. Kei, you have the floor for 5 minutes.
Thank you for the introduction. I'm Kei, and I'm currently a postdoc at the Technische University of Berlin. My background is actually in social science and water governance, but I'm also a founder of an early stage startup working on circular economy. And today I'm going to talk about my startup's business initiatives to solve harmful algal blooms and also to achieve a circular economy in Berlin. And the background, so I'm looking at the next slide, please. Looking at the problem of a harmful algal bloom in lakes in Berlin that produce toxins and negatively affect people's health and the planet. So in Berlin, several lakes have this algal bloom problems since 2017. And for example, several dogs died from drinking the water from the lakes, and scientists are currently investigating this issue. Next slide, please. And for the case study, I'm looking at the Lake Tegel in Northwest Berlin. So the lake has not reached good ecological status of the EU's Water Framework Directive yet, and it also serves as a reservoir for drinking water through bank filtration and artificial groundwater recharge. It needs a stable control of algal biomass, particularly of cyanobacteria, remains a management priority. And the local authority gives warnings about the risks on human health and the environment to the public, but so far no effective measure has been taken to tackle this issue. And the impacts of these toxic cyanobacteria are not fully known yet. Next slide, please. So the possible causes, according to existing research, are the occurrence of genus Trichonema producing anactocin A. So there's a need for further investigation of potentially toxic non-bloom forming cyanobacteria in less eutrophic water bodies. And second, wastewater residue in surface and groundwater. There's a question of capacity to remove contaminants through bank filtration in Berlin. And there's also overflows from the combined sewer systems when flooding. And third, pharmaceutical micropollutants. It's also important to look at the lake-specific mechanisms, including inflow and outflow balances and seasonal density stratification for the transport of the micropollutants. And lastly, climate change is an important factor to consider because heat waves and lower water levels definitely affect the sensitivity of the lake. And next slide, please. However, if treated properly, cyanobacteria or microalgae can be used for many good purposes, and it reduces carbon dioxide, phosphorus, and nitrogen in freshwater ecosystems. And it also promotes biodiversity, and it can be used as a sustainable source of nutrients and food additives, or can be also used as biofertilizer or soil stabilizer or bioplastics or biofuel. And next slide, please. And the next. Thank you. So for the solution, we will remove the toxin and treat them in the most energy efficient way and investigate what kind of materials we can extract as a result of the treatment. So we want to sell this solution as a service. And here are the potential materials we can get as byproducts in the right side of the slide. And through our lab process, we produce resources out of these algae, cyanobacteria. And it also captures CO2, and water will be reused over and over again. And can you go back to the previous slide? And the further byproduct of toxin removal or biofertilizer is especially attractive because there's a global shortage of phosphorus, and producing fertilizer locally is urgent also to build a self-reliant system. And there's a demand for shifting to locally produced fertilizer. And next slide, please. And where we stand now, so currently we are preparing for experiment in a lab and a partnership for technical assessment with Armin, he's a water chemist at the German Environmental Agency, is ready. But however, main challenges could be the assessment of regulatory conditions for sampling and installing decentralized treatment system. So as a next step, we will discuss this issue with local water utility, and I'm also planning to make policy recommendations based on this identify the regulatory barriers through the process. And lastly, increased energy costs for treatment is also a challenge. Last slide, please. And thank you for your attention, and I'll be happy to answer any questions. Yeah, this is helpful.
Thank you, Kei, for your presentation, and also for presenting a business case out of pollution. I think that's a good example of a life cycle approach, if you were to ask me. We'll go straight on to the next presentation, but I also invite the speakers to respond to some of the questions in the Q&A box, if you can. We will now move on to a more of a policy-oriented abstract on the management of emerging pollutants with a circular economy approach, lessons from developed countries in this field, and suggestions for Northern Cyprus. Farhad Bolouri, you have the floor for 10 minutes. Over to you.
Thank you. Hello, everyone, and nice to meet you. Yes, our presentation titled Management of Emerging Pollutants with a Circular Economy Approach, Lessons from Developed Countries in this Field, and Suggestion for North Cyprus. It's written by my supervisor, Professor Hüseyin Gökçekuş, and me, and I'm presenting this work for you. Next slide, please. Yes, as you see the table of contact, we have introduction, methodology, our result and discussion, and conclusion. Next slide, please. Yes, as introduction, as you know, emerging pollutants are chemical and compounds identified as dangerous to environment, consequently to the health of human. Presently, they have been labeled emerging because of the rising level of concern linked to them. Next slide, please. Yes, as circular economy, we know it is a type of economy that is an alternative to traditional linear economy that was only take, make, and waste, but it seeks to reduce waste, recovers resources at the end of product's life and channels them back into production. And as you see in the pictures, instead of take, make, and waste, here you have make, use, and recycle. And thus scientifically reducing pressure on the environment. It is the goal of this circular economy. Next slide, please. Yes, and here, as you know, but we want to just remind, it is the country classification with the United Nations. You see developed countries. You see most of them are European countries. Most of them previously listed in this list, and some of them came after that one. Some other countries, we have Australia, Canada, Japan, New Zealand, and United States, and major developed ones that listed Canada, Japan, but more of them are from EU too. And next slide, please. Yes, and as methodology, we have data, and we get in our data from the TRNC, Turkish Republic of North Cyprus. In the next slide, I will explain more. And emerging pollutants, lessons from developed countries. These are our data. After that, we got a knowledge, and we are going to circular economy approach. And now we have some criteria, and we goes to the impact of policies, and we see the suggestions for North Cyprus. But as methodology, we using library resources, measuring the manner and extent of the impact of policies, if it is possible. and after that the condition of Northern Cyprus, and after that using the experiences gained from the cities investigated in the session of library studies from the developed countries to North Cyprus. Next slide, please. Yes, our case study is North Cyprus. In Turkish, we say Kuzey Kıbrıs. Officially, it is Turkish Republic of North Cyprus, TRNC. And in your photo, you see the Cyprus is in two parts, north and south part, and a region that it is with United Nations buffer zone. Next slide, please. Yes, up here I want to show the results. For example, United States has USGS. They defined what is the emerging concern, emerging pollutants, and they said it is important to take the data. The most important part of this research and solution are data. I read from their report. They said emerging components or components of emerging concern can refer to many different kinds of chemicals, including medicine, personal care, or household cleaning products, lawn care, and agriculture products, among others. These chemicals make it into our nation's lake and rivers and have determinant effect on fish and other aquatic species. And also it is not good for human health, as you know. So you see, they don't have any special solution for it. But in the first step, they said the data is very important to gain data. Because it is very new for all of the societies, this issue. Because of that, they highlighted the getting and gained the most and more data for this problem. Next slide, please. Yes, for European Commission, they have Norman. I read from it. In 2005, the European Commission funded the Norman project to promote a permanent network of reference laboratories and research centers, including academia, industry, standardizations bodies, and NGOs. Since then, Norman has facilitating a more rapid and wide scope exchange of data on oceans and effort of continents of emerging concern, improved data quality and competitive via validation and harmonization of common sampling and measure methods, and etc. And as you see, from 2005, around 17 or 18 years ago, they are focusing on gathering data too, because we don't have enough data for getting solution for this problem too. Next slide, please. Yes, here you see Canada, the Environmental Protection Agency, or EPA of Canada. You see here it said both Environmental and Climate Change Canada and Environmental Protection Agency are reporting that CECs are increasingly and consistently being found in groundwater, surface water, municipal wastewater, drinking water, and food sources. Besides personal care products, common seas include pesticides, pharmaceuticals, industrial chemicals, and surfaces. They are finding their way into waste watersheds because traditional water treatment such as chlorine and ultraviolet or UV have shown to be largely effective at treating and removing the contaminants. I don't read the blue part, but it is show the importance of this solution for this problem. but they don't have any solution to, because this is a problem that we don't have enough data in, for example, a developed country like Canada too. Next slide, please. Yes, I couldn't, and we couldn't find some data from Japan, but for the last case study, we got this one from Australia, research center and laboratories. They aim to minimize the adverse impacts from anthropogenic emerging contaminants or pollutants on public health and the environment. And they have for their vision, mission, and what is their role. But if you focus in the role, you see they focused on gathering data and calculate the risk of these components in the water and wastewater, and take some data scientists, policymakers, and work together. In the last sentence you see. So they are trying to get and gathering data too for Australia. Next slide, please. Yes, according to these countries that we mentioned, and according to review of the management status of developed countries, regarding emerging pollutants, it can be concluded that due to the status of identifying these pollutants and the importance of the valuable data on these items to make decision about how to manage them, it is essential to address this issue in Cyprus as well, and to collect emerging pollutants data in the entire region carefully for consecutive years. Even data exchange with south part of Cyprus can be proposed to collect data for all Cyprus as a whole, so all the correct management decisions are applied. Also, according to the circular economy approach, it is very important that during decision-making process for the management of emerging pollutants, the nature of circular economy is also considered. For example, emerging pollutants are used in the manufacture of related products in order to cause less damage to environment. Exactly what is done in the case of car batteries, some computer parts, and etc. Next slide, please. Yes.
Farhad, sorry, I'm afraid I'll have to interrupt because your time is up. Can you do your conclusion in one sentence?
Okay, the conclusion is the same.
Thank
Our last slide. Okay, so next slide, please. Thank you so much for your attention.
And thank you for your interesting presentation. We go straight on to the next presentation, and we'll move to Rajasthan, India, with a presentation highlighting the impact of emerging water issues on human health. I would like to invite Menaj Sheikh. You have the floor for 5 minutes.
Yeah, thank you. Hi everyone, welcome to my presentation. I am Hanaz, a research scholar at IAS University, which is located in the Rajasthan state of India. And as you can see on the screen, our topic for today is emerging issues of water and its impact on health, a case study of Jaipur city, Rajasthan. Next slide. Next slide, please. As we all know that water available on earth is very limited, but the population is increasing, and this has and the increasing population is increasing very much pressure on the water resources, and this has led to a shortfall in between the focused demand and available supply of water. Next slide. Since time, many national and international organizations are working towards these water-related issues, like the UNO's Sustainable Development Goals even talk about it, and they have also addressed the issue of water related. Indian cities are also facing many major water crises. Like one is the supply of water, and another is the quality of water. since India is the second most popular country in the world, so its demand is increasing and the unsustainable use has degraded its quality. So in the same line, we have chosen, next slide please. So in the same line, we have chosen Jaipur is the capital city of Rajasthan, the study area where we can study the demand of water and its impact on health of the Jaipur. Rajasthan is the water deficit zone, and so is Jaipur. And being an urbanized city, the population is increasing rapidly. Same as manufacturing industries, and all have increased the demand on water, and its supply and quality are degrading day by day. Next slide, please. There is a map of Jaipur city. Next slide. The objectives we have already highlighted that emerging issues and its impact on health. Next slide. This research hypothesis is that whether the water is not as per the WHO standards, and due to this, people are suffering diseases due to unhealthy water. Next slide, please. Next slide. So the methodology adopted here are the personal observations and field surveys. And we have also collected some of the data from the government reports, like from Public Work Department and municipal corporations and all. So the data reveals that, next slide please. The sample study shows that Jaipur receives near about 65% of contaminated water, which is highly in concentration of TDS, concentrated and contaminated by bacteria. Next slide, please. Next slide. This map shows that the water table or groundwater table of water is rapidly going down, and it is below 70 meters below the ground level. Next slide. The results are that some of the zones, areas of Jaipur is consuming high water in which is rich in fluoride. So this has led to many negative impacts on health, like abdominal pain, nausea and vomiting, dental fluorosis, and it has affected almost all the body parts of humans. Next slide. The next contaminant is nitrate, and this one. Due to excess use of nitrogenous fertilizer, organic waste, the nitrate concentration in water is increasing, and this has led to very unsafe conditions in infants like blue baby syndrome. This has also led increase in colon cancer and many respiratory diseases. Next slide, please. So we can conclude that to tackle all these problems, it is demanding that proper rainwater harvesting system, groundwater recharge system should be enforced effectively. Ensuring safe and regular water as per the WHO standards is also mandatory. Next slide, please. Policy implications. Some of the as last, I would like to conclude that some of the steps must be taken in order to save the mental environment. Effective steps must be taken, and this should be on the public participation and should be dependent on us. Thank you.
Thank you, Minaj, for your interesting presentation, and I hope you get to share your results with the authorities as well. Now the next abstract brings us to Dhaka, Bangladesh. Mezanur Rahman will make a presentation on the spatio-temporal assessment of chlorine residual in the water distribution system of Dhaka city. Mezanur, we look forward to learning from you more in the next 10 minutes. You have the floor.
Okay. Hello everyone. Welcome to my presentation. I'd like to present the topics of spatio-temporal assessment of chlorine residual and the water distribution system of Dhaka city. So next slide, please. Actually, nowadays, majority of the people of Dhaka city in Bangladesh are completely depending on supplying water from production to well. It's a underground water actually. So it's under Dhaka Water Supply and Sewerage Authority. for household potable water use for ensuring the water safety. However, proper understanding, characterization, and prediction of water quality behavior in the drinking water distribution system are very critical to ensure to meet regulatory requirement and customer-oriented expectation. Next, please. The main objective of my study to assess the effectiveness of the current chlorination system in the water distribution system of Dhaka city, and then prediction of the concentration of residual chlorine over space and time. Actually, the residual chlorine is an important disinfectant to make the water safe before drinking. And also the calibration and validation of the hydraulic model using time pattern. It was used through the EPANET software. Actually, EPANET is a environmental management protection. Actually, it's a software for hydraulic and water quality modeling, and also the determination of sensitivity of the residual chlorine model. Next page. The main issues and problem of the study area is there are 100 DMS, that means the district metered areas, to improve the water supply network of Dhaka city. Though there is a protocol for chlorination system at the pump or pump station of production tube oil, but monitoring of residual chlorine is found absent in reality. Chlorine is administered rather arbitrarily, and its effectiveness in the water distribution system remains largely unknown. So, and the concentration of residual chlorine within a water distribution network vary in accordance with the variation both for location and time. Next, please. Next slide, please. The methodology of the study is, sorry, the previous slide, please. The methodology is, first of all, I had to select DMA, district metered area. Actually, it's a distribution network. It's an existing hydraulic distribution network. But I have to set through the GIS database and GIS database, EPANET. Then I set first. First, I have to measure the initial concentration of residual chlorine in the existing water distribution system of the DMA. Then I predict the concentration of residual chlorine over space and time through the EPANET software. I used EPANET 2.0 version software as a predictive tool. It's a very user-friendly software. The United States Environmental Protection Agency developed by the Roseman, Dr. Roseman. He developed this software. Then a collection of existing water distribution network, it's a time pattern and other hydraulic data. Then we have to determine the bulk decay rate from the laboratory of BUET, the environmental laboratory. Then I had to find out the wall decay rate. Actually, when the water flows through the pipe, then some decay happen. So I had to determine the data from the calibration, validation of a residual chlorine model. Next, please. Next slide, please. The result and conclusion derived from my study was actually previous slide, please. The average value of the KB, that means the bulk decay rate, was found negative 0.2975 per hour, and the value of the wall decay rate was achieved 0.0065 feet per second, and we calibrated in 2 points, and the predicted and observed time series value of residual chlorine for node 172, and it found that the KB value of 0.2975 and 0.0065 kW value fit with the residual chlorine observed data. So we have taken the data KB 0.2975 and KW equal to 0.0065 feet per second. So next slide, please. Next slide, please. Previous slide. Then accordingly, we simulated. Next slide. Then we matched with the observed residual chlorine data. Sorry. Okay, finally, we got some. Excuse me. Hello. The result and conclusion derived study continued. If we look at the map, it is showing that the contour plot of baseline residual chlorine scenario is very light, but if you see the contour plot for fifth residual chlorine improvement scenario at 14 hours, then it looks improved. Actually, the coverage of the residual chlorine is improving through the more injection of chlorine at the source. So we are getting the better result in the water distribution system through the EPANET model. Next slide, please. Yes, from the study, we got some finding that the value of KB is significantly higher than the literature value due to the high temperature and organic content, the high organic content. Also, the KW was nearly similar to the literature data. We also say that more than 50% pipe are found with zero residual chlorine at baseline condition. But when we improve the injection of residual chlorine, then the coverage of the residual chlorine in the network is showing better than the baseline data. And only we have seen that only 2 injection points are available during my study. So this is a good point, and this is a good model to predict and to monitor the residual chlorine over the existing network of any city like Dhaka city or any densely populated city, because ultimately our the water source, the surface water, the lake are getting polluted through the human excreta, and the other emerging pollutant are doing the surface water very contaminated. So first of all, we have to ensure about the water quality, and what is the either it is pathogen free or fecal free water. So due to save the drinking water, we can use the EPANET software to predict and to assess the existing residual chlorine of any existing network. But finally it was not possible to cover 100% chlorine coverage in 24 hours, because there are some critical point. So for some critical point, we have to inject some chlorine area-wise. So next slide, please.
Great. I was going to invite you to make a conclusion in 1 sentence.
Okay, thank you, ma'am. Thank you all. If any question, I will like to answer.
Marjin, I just want to bring the attention of the panelists to the Q&A box. We have a couple of questions, and maybe they can have a look, and because we don't have time at the end of the session to answer all the questions.
Yeah, thank you so much, Dahlia. So to the presenters, please make sure you have a look at the Q&A box. And to the audience, we are about 200 people online. Please keep sharing your questions. They've been really interesting. So thank you so much, Ms. Anour, for your presentation. And now we'll go to the next presentation.
Okay.
Actually, we had planned a presentation by Christopher and Dio on the communal construction of water catchment areas to regulate sustainable supply and water cost. However, he's not been able to connect, so we will move straight on to the final presentation. But you can see Christopher's presentation on the website. It will be shared over there. So the last speaker of today is Valeria de Carvalho Santos Ebinuma, and she will introduce us to the world of microbial colorants with her presentation on production and life cycle assessment of microbial colorants. Valeria, you have the floor for 10 minutes. Please go ahead.
So thank you. Can you hear me? Yeah. Okay,
Very
so
well,
thank you. So good afternoon, everyone. I am Valeria de Carvalho Santos Ebinuma at São Paulo State University from Brazil. And first of all, I'd like to thank you, the organizing committee, for the invitation to make this presentation that is entitled Production and Life Cycle Assessment of Microbial Colorants. Next, please. So, to make a look at you about my university, we are in Brazil, in the state of São Paulo, in the city of Araraquara at São Paulo State University, as I said before, in the Department of Engineering of Bioprocess and Biotechnology. And I'm going to talk a little bit about the colorants. That's the main subject of my work. So the industry has taken actions to color different kind of products, improving, sorry, next slide, please. So, oh, thank you. So to make a contextualization about our research group, my research group works with the colorants, and the industry has taken actions to color different types of products, improve the consumer acceptance, and thus the product sales. And so colorants can be found in different places, and they are involved in the process, in the storage, processing, packing, distribution, or it can be used to preserve some characteristics of the product. So, for example, in the food applications, the colorants can protect the flavor and the vitamins from photodegradation, for example. The colorant market is growing day by day and is expected to achieve around 68 billions in 2023, growing around 5.4 between the years of 2016 and 2023. And this market is composed of synthetic artificial colorants. We have natural identical colorants and the natural colorants. We know that the synthetic colorants are the most used. However, there are problems not only during the process to obtain these colorants, but also after the process. So, for example, in the textile industry, there are several problems with the discard of these synthetic colorants to water, and this is a big problem that the natural colorants can be used to replace the synthetic colorants. Next slide, please. The natural colorants are composed of the synthetic produced by insects, microorganisms, and plants, and they are a diverse chemical structure of compounds can be found and produced by these organisms. However, with the development of the bioprocess and the biotechnology, the production by microorganisms has increasing day by day, and this is important. Why? Because we can secure the production without several problems with, for example, the raw material supply. We can improve the production studying the batch, and we can find not variation between one production and the other. And generally, the natural colorants produced by microorganisms are more stable than the others produced by plants, for example. Next, please. In this way, the goal of this study was to produce red colorants by the filamentous fungi Thalaromyces amistokiae in styrotank bioreactor, and to estimate the environmental impacts of this process using life cycle assessment. Next, please. So the bioprocess to obtain this colorant was composed of 3 steps. The first one is the production that is shared in the pre-inoculum, the inoculum, and the cultivation that occurred in styrotank bioreactor of 4 liters. And after there are separation between the biomass and the liquid containing the colorant, and this liquid containing the colorant is submitted to extraction steps using liquid extraction using organic solvents. And to make the assessment, next slide, please. And to study the life cycle inventory, this is the system boundaries. So we analyzed each part of the process that is composed to obtain these natural colorants in scale, in lab scale. So you analyzed the water supply to, for example, cleaning the bioreactor and the water needed to make this process, and how this water, for example, was discarded in effluents, and which is the waste of the treatment of all the process. And so we made this inventory, and the life cycle inventory was using the eco-event v3.5 database. Next, please. So the first part of study was the production, and we analyzed 2 in pillars to produce the colorants. The first one was Russian turban, and the second elephant ears in pillars. And we had a difference in the hair pellets formation when you used one kind of Russian turban. This is quite interesting because although the biomass is not the subject of this work that I'm presenting here, this biomass you are used to other purpose to produce, for example, biogas. And so the dense pellets formation was interesting for this application. And considering this, the formation of the microorganism, the growth of the microorganism, and the production that was higher, use elephant ears in pillars, it was the condition used to the life cycle analysis. Next, please. So when you analyze the environmental sustainability assessment for the production of this colorant, we made first 2 analyses. The first one was the total climate change, and the second, the primary energy demand. However, to both analyses, the main problem was the cultivation step. And this was around 65% of the total problem in the total climate change, followed by the pre-inoculum preparation. And in the case of the primary energy demand, it was 63%, followed by pre-inoculum preparation. Next, please. When you analyzed other problems, we also saw that the cultivation step was the main problem. And why it? Maybe, and we analyzed it because of the time and needed for these steps, that was 168 hours for each one. And considering the electricity, this was the main problem. So in Brazil, have the hydroelectric as electricity, and its demand of energy is too high. And if you consider that you are using organic solvents, for example, in the extraction steps, these organic solvents can be replaced, can be reused in the process. So we can use more than one time, and this was not a big problem for this process. Next, please. So the environmental sustainability assessment indicates that the cultivation step is a major host pose in the red colorant production by Thalaromyces amistokiae, mainly due to the process time and the associated energy requirements to this process. So although this natural colorant has a big market and can be used in several places to replace the synthetic colorants in order to reduce the environmental problems, what we can do, since we have a problem with this process as well. So future studies that we are trying to, and we're doing now is, for example, to make improvement in this process in order to reduce the time of the cultivation step. And second, use low carbon energy sources. In this way, we can reduce the problem about the electricity, for example. Next, please. I'd like to thank you everyone for the attention and my research group that's called Bioproduct Production and Purification Lab. And I invite everyone to follow us in the Instagram. And I'd like to thank you as well for funding agencies for support this work. Thank you.
Thank you so much, Valeria. This industry of colorants was very new to me, so I've learned a lot. Now I'd like to, I'm looking at my co-moderator, Dahlia Sabri. Can you please talk us through any of the questions posted in the chat?
Thank you. Yeah, actually, we have a couple of questions. I think this question is addressed to Mehnar. The question is it possible for the river water to purify itself after some distance due to pollution source like sanitary wastewater? So would you like to answer this question, Minaj?
Okay. No, I don't think it is possible. It may be possible if the river water, there is a much water in the river. There is proper rainfall, or the
Minaj, I don't think we can hear you. Okay, can you please write down the answer? Maybe it's better because we cannot hear you. The connection is breaking up. I'll move to another question. I think this one is related to what Mizanur was presenting. It's your model. Do you consider the biofilm, TOC, and disinfection byproducts of distribution system in the model you have presented?
Hello.
Yeah, please go ahead.
Yes, I have tested so many parameters like pH, alkalinity, hardness, color, ammonia, total coliform, fecal coliform, TOC, carbon dioxide, iron, arsenic, chloride, and manganese. TOC is the significant parameter actually. So I consider that parameter into my model.
Okay, we have another question for you. First, Rina, she's congratulating you on your presentation. And the question is the disinfection done just before the filtration equipment and after sedimentation efficient?
Sorry, question again, please.
Is the disinfection done just before the filtration equipment and after sedimentation efficient? Is it efficient?
No, it is not done actually. No. Actually, it's a study. It's a case study. I just followed the study with the other study in other place. So I just followed that study, and I observed how the chlorine is decaying through the distribution system from the source. Actually, we observed the source water quality parameter. First, I checked the water quality of the source into the laboratory. Then I observed some field water quality at some specific point, and then I calibrated that data, and we got the bulk decay rate. So these two two parameter is the main actor of the water quality of the residual chlorine model that I presented. Actually, the residual means how we can monitor that there is a presence of organic contaminant or microorganism or other substances are there. So we can easily monitor the presence and leakage and also the effectiveness of the chlorination system. Either it is sufficient for the to remain to make it 0.2 at least at the household level. So we can easily estimate that quantity required to inject at the source. So this is my study actually.
Okay, thank you, Ms. Noor. Actually, for the sake of time, we still have a couple of questions unanswered. So I
thank you, ma'am. Thank you.
I encourage all the presenters to have a look at the questions and please answer them, and we'll place them on the website of the conference. Back to you, Marjin. Thank you.
Thank you.
Thank you, Dahlia, and thank you everyone else for all the questions and answers. We've now come to the closing of the session, but not before I give a million thanks to all the presenters of the abstracts. And I also know for some of you it's late at night, so thank you so much for being willing to present your work and for sharing your knowledge with us. Also a special thanks to our keynote speaker, Styliani Avraamidou, for opening the session for us. And before I really close the session, I have some final points for you. If there's any remaining questions that have not been answered, we will share it on the conference website. So please check the conference website regularly to find the answers to your questions. And also there is an excellent selection of conference posters at www.iwraonlineconference.org, where you can see, in addition to all these presentations, some additional posters that have been made. And if you have any questions about these posters, again, send us an email to online.conference@iwra.org. And with regard to the PowerPoint presentations, they will also be made available on the conference website, along with a video recording of this session. And you may not see them, they're not visible, they're very humble, but there is a huge team behind organizing this conference, and I would like to thank the IWRA UNESCO team in organizing this conference. And also we have two rapporteurs for this session, Atikur Rahman and Julie Robitaille, who will provide us with an interesting summary after this session. And I would also like to thank Ali Fares, who was part of the scientific committee of the session. And of course, thank you to all the speakers on behalf of UNESCO and IWRA for your contributions with interesting research. And we thank all the participants online, around 200 just now, for your participation in this session. So thank you all very much.